Studios of Way Happy. This is Mr. Meyer, and we are talking 18C, increasing and decreasing. So remember in pre-calc or wherever, you had a function, and there was a little man that we put on the function, and you always read a graph from left to right, like you're reading a book. And if the little man's walking downhill as he walks on the graph, then that function is said to be decreasing at that point. And if the little man is walking uphill at that point, I can make him move. If he's walking downhill, that's decreasing. And then if he starts to walk uphill, it's increasing. So the function is increasing over here. And we talk about the x values, and it's decreasing over here. We talk about the x values also. So, just so you know, it's always really confusing about when the function is increasing or decreasing. Do we include zero? Since it is included in both, you would say it's increasing from 0 to infinity, or it's decreasing from negative infinity to 0. And yes, you are more than welcome to include it, because if you read over here to the side, I really like the way the book explained it. It said increasing and decreasing is really just it's associated with intervals and not points, so over an entire interval. So here's example 9. They say, when is the little man walking uphill and when is he walking downhill? So increasing. I would say the graph is increasing. The graph is increasing. So when is he walking uphill? Well, that would be all the time on the left, right? He's over here. And that would be all the time until he gets right here to x is -1. So it's increasing from, or I would just say increasing. I'm going to do this, negative infinity to -1. And I'll put a bracket because, again, it's a range. And you could also do the rounded bracket saying not including -1, but it is more than okay to say that range. So people, that don't like that notation would say negative, or no, I'm sorry, all x's less than or equal to -1, right? So that's the way the interval is written. It's the graph is increasing blank blank, and where else is it increasing? Well, the little man's walking downhill for this stage, but then he starts walking uphill again. Right here, he starts walking uphill, and so that's at the x value of 2. So I would say 2 to infinity, right? And that's how I would say it was increasing. Part B, I would say the graph is decreasing in between there, right? The graph is decreasing -1 to 2, right? Or if you wanted to, by the way, this was x is greater than or equal to 2, and then this would be all the x's less than 2 but greater than or equal to -1. So I don't use that notation as often because it seems to take longer and a little bit of thought, where smaller number on the left in interval notation seems to work very well. All right. So what does that have to do with derivatives? Well, think about that. That means if the graph is increasing, then the derivative must be positive. Because remember, the derivative is the slope. And when the slope is positive, then we have an increasing graph. When the slope is negative, we have a decreasing graph. Beautificent, right? So, what's going to be super important here is that you take the derivative, you set the derivative equal to 0 to find critical points, which you may remember from pre-calc again, where we found critical points that then we tested each side of the graph. And that's what we're going to do again. We're going to do these fancy sign diagrams, right? It's little sign charts. And that will tell us what's going on. So here is my work for number 10. 10A. So find the intervals of increasing when it's increasing or decreasing. So f of x is that. So I'm going to find the derivative real quick because that tells me about the slopes. And that will be -3x squared plus 6x plus 0. I'm going to set that derivative equal to 0. So we call those critical points, or this book is going to call them tomorrow stationary points. I'm going to set f prime of x equal to 0. Therefore, 0 is equal to -3x squared plus 6x. What could you factor out? I could factor out a 3x in both of them. Maybe even a -3x if you want. And I would be left with x minus 2. And therefore, x is equal to 0 for this one, or x is equal to 2 for this one. Now, what does that mean? Those are critical points that you should put on your sign chart. So here's your sign chart, which is a number line of all the values of x, right? And x is 0. That point should go on here. So I'm going to do an open circle there. That's when it equals 0. And another critical point is at 2. So 1, 2. Here's another one. And what critical points mean is the graph is changing on either side. And so let's test. How do we test? Pick anything smaller than 0. I'm going to pick -5, right? The easiest place to plug it in is your farthest down factored form. So if I plug in -5, I would get -3 times -5 is positive, and then -5 minus 2 is negative. So I'd get a positive times a negative, or I would get a negative. Whoa, I would get a negative answer for all of those. So anything over here is negative slope, which means the graph is decreasing over there. Then between 0 and 2, pick any number between 0 and 2. The graph will behave all the same between the critical points. Unless there was asymptotes or something, then be careful. Make sure you put those on your number line. Anything between 0 and 2, like 1. If I do that, I will get a negative number, right, from the first part, and then a negative number from the second part multiplied together is a positive. So all of these are positive. The graph is increasing between 0 and 2. And then after the number 2, what happens? Let's plug in, after the number 2, let's plug in 100, because that's on the right side of 2. If I plug in 100, I would get negative times a positive. So that would be negative. So the graph is decreasing again. So now I can tell people that it is increasing. Do you want to do first? Yeah, they have increasing first. Increasing from, all right, I don't even have to, I'm just going to put increasing 0 to 2 and decreasing from negative, oops, like a parenthesis with negative infinity because it's a concept, not a number, negative infinity to 0 and 2 to infinity, right? Those are the parts that it is increasing. That's the 2 times you will find this graph to be increasing. Beautificent. All right. What about the next one? B. Same thing. I will find f prime of x, which will give me the derivative 12x cubed minus 24x squared. Yuck, right? Then I will set the derivative equal to 0. 12x cubed minus 24x squared equals 0. I will factor out a 12x squared and be left with x minus 2. And so that means 0 and 2 are our numbers that need to be on our number line. So 0 and 2, wow, this feels familiar, right? 0 and 2. And so when I do that now I can go ahead and test all the different intervals. So again, picking something smaller than 0. Well, you know what's funny is pick something smaller than 0, like -100. It's going to get squared. So that answer is always going to be positive. So really, this piece doesn't have anything to do with this because it's always positive. So really, you're just going to plug it into this piece. You can do it into both, but I'm just saying that first one doesn't really matter. So if I plug in a negative, I'm going to get a negative. If I plug in anything between 0 and 2, I'm going to get a negative. And if I pick anything bigger than 2, like 5, I'm going to get a positive. So the graph is increasing. I'm going to do first again, increasing from 2 to infinity. It is decreasing from negative infinity to 0. Then something's happening weird at 0. And then it goes back to increasing from, or decreasing from 0 to 2, right? So be careful. Now, is it okay to say that it is decreasing the entire time? Sure. I mean, most people will say, oh, like, hey, look, something weird happened here. But since it's a range, you don't have to really break it apart, that range, since it wasn't an asymptote. And so you're more than welcome to say that it is decreasing every time under 2. So I will say decreasing from negative infinity to 2. And there you have it. All right. What about 11? 11 now, they're going to say, hey, show us that. So now they're going to crank it up on us, right? They're going to crank it up on us and make it a little more challenging. So the first thing they want to do is for us to find the derivative. So that looks like the Lodi-High rule. So I will do that. So A, right? Lodi-High. So the low, x squared plus 2x minus 3 times the derivative of high, d high, is 2 minus high, 2x minus 3, times the derivative of low, x2x plus 2, all over low, x squared plus 2x minus 3 squared. Now, probably would have been a wise choice to factor first and see if anything could have happened, but it is, alas, too late. Um, so let's see what I can actually do her. Um, I can kind of clean this bad boy up. So if I distribute the 2 through, I'll have 2x squared plus, because you can see mine does not look like theirs. So I got some work to do. Plus 4x minus 6. And then here, what is this? This is, if I do this together, it's going to be 4x squared plus 4x minus 6x, so minus 2x, and then minus 6, but then it's all subtracted. So minus 4x squared plus 2x plus 6. So all of that goes in there. And now I can see, over, what is this? This is, if I look at their answer, it looks like it was factored. Does it factor to 3 and negative 1? It would factor to x plus 3 times x minus 1, right? That does FOIL out to that, and that whole thing is squared. So that looks pretty good. Thanks for the help. Negative 2x squared. What do I have? A 6x. And those are gone. And so over x plus 3 squared, x minus 1 squared. And now I can finally, kind of give them their answer, which is pull out the negative 2x and show us that it's x plus or minus 3. And it is. So I feel pretty good. X minus 1 squared, x plus 3 squared. So that agrees with their answer. Check. And I would say that, right? I would be like, therefore, and there it is. And draw a sign diagram. Okay. All right. And now let's look at where our zeros are, right? So our number line, and we know our solutions are at 0. I guess I should use a different color. We know that 0 is a critical point, right, from this one. So we know 0 is a critical point. And we know that 3 is a critical point. So we want to make sure we have those on the number line. Now, those are zeros because remember, a fraction is equal to 0. And that's what this is the derivative. And the derivative is equal to 0. It's a fraction. It's equal to 0 when the numerator is equal to 0. However, there's also some things about fractions. We're not allowed to have things happen that are in the denominator, like 1 is not allowed, right? So that's an asymptote, right? So we're not allowed to have 1. That becomes a critical point. And negative 3 becomes an asymptote because that's not allowed to happen. Those go to infinity and negative infinity. So we have to be super careful there. We have to include those also. So all 4 of these have to be included. Now we can finally test regions and make our sign diagram. Now, our sign diagram, remember, we're going to be plugging in some numbers. Well, the bottom is always going to be positive and positive because it's being squared, so it doesn't really matter. So let's go ahead and figure out what we plug in. So plugging in something smaller than negative 3 is like negative 100. And if I plug that into the first one, I'm going to get a positive and then a negative. So all of these are negative. Plugging something in between negative 3 and 0, like negative 2, is going to give us a positive and a negative. So all of these are negative. Plugging something in bigger than 0, but smaller than 1 is like a half. So I would get a negative out of the first one, and a negative out of the second one. So I would get a positive. Oops, right here. Plugging something in bigger than 1 but less than 3, so let's say 2, I would get a negative out of the first and I would get a negative out of the second. So that is going to be positive. And then something bigger than 3, a million. And so I would get a negative and then a positive. So all of these would be negatives. So you can see that things are. Oh, it says find the intervals. I thought I was going to have to graph. Part B says find the intervals for increasing and decreasing. So I would say it's increasing. It's increasing from 0 to, and you can actually include the 0 if you want. Doesn't matter. 0 to 1. And then, but at 1, there's an asymptote. And then at 1 to 3. And now you might say, like, hey, before you just said from 0 to 3, but this time we have an asymptote that has caused discontinuity, and we can't talk about increasing or decreasing. It's not a point, right? This is an actual asymptote that causes the fit, and so therefore we have to break this up into two different parts. And then what about decreasing? When is it decreasing? So again, remember, over a point's fine, but I can't do it over an asymptote. It is decreasing. So there again is negative infinity to -3, and then it's decreasing from -3 to 0, and then it's decreasing from 3 forever, so to infinity. And so there you have it. It is decreasing in that range and increasing in that range. And that's it. Stay happy. And I will see you next time.